Hey there again. Let's finish up chapter 6 today with polar coordinates. So we're going to be working on a coordinate plane again, however they're polar coordinates instead of rectangular coordinates. Instead of the x and the y where we go over and go up, we're going to do something called the polar coordinate system. Polar coordinates, instead of going left or right and then up and down, we just go out and around. Okay, so the two pieces of information in your point is a radius and a theta. How far out should I go, and then how far around do I go on the polar graph paper? So this is what polar graph paper looks like. It's circular instead of rectangular. And so if I'm looking at the point A, and hopefully you can see this point A right here, it is over, and each of these circles has values on that. So that's a radius 1, 2, 3, 4, 5. So I'm going out to a circle of radius 5, and then I'm rotating around 30 degrees. So A would have the polar coordinate of 5 followed by 30 degrees. Now this of course can be degrees or radians, so it could be pi over 6. So it just depends on which kind of graph paper you have, or which mode you are in. So B right here would be 7 for your radius, and then you can see these are 15-degree increments, so that would be 75 degrees is where that would be. Okay, so there's B. C looks like that would be 180 degrees here, so minus 15 would be 65. And that is a radius of 5 again. So C5, 165 degrees. And so I just want you to be able to kind of visualize what it looks like. You can use negative rotations as well. So D could be 4, and then I could just rotate negatively. That's 15, 30, and then 45, so I can do negative 45 degrees. And in fact, you could do that for all of these. These all could have negative rotations if you wanted to. So this one over here, E, could be 8. And then it looks like 150 degrees negative. Certainly you could give the positive rotation as well, so that would be 210. So it could be 8, 210. And so there's more than one way to give those locations. But again, it's just out and around, or out and negative rotation for polar coordinates. What we want you to be able to do is be able to convert back and forth between both. Okay, so if here's A, and it is 530 degrees, where is it as a rectangular? How far over do I go, and how far up do I go? Okay, so I want you to be able to turn that r theta into an x, y. So you can see it's going to be less than 5, and then if we just kind of did this sort of thing, and over here it's going to be, that's 1, 2, a little more than 2, but less than 3 up. So we want to be able to turn it into rectangular, and then vice versa. Take a rectangular and turn it into polar. Okay, so here's just another example in your notes on how you give location. And so 2 pi over 3, we know that pi over 3 is close to 60 degrees, so that's just out 60 degrees. This is one with a negative radius, so I just want to share that with you. I don't think you're going to be assessed on it, but a radius of 1, so you can go out 1 and then around 3 pi over 4. But since that's a negative 1, you would just drop this way, negative instead of that way, positive. Okay, so don't worry too much about that. I don't think you're going to be assessed on that, but just know it's a possibility. And then here's that negative rotation we just talked about too. So a radius of 3 and then a negative rotation at 45 degrees. Okay, but like I said, I want you to be able to convert back and forth. And so these 4 equations, super important. Make sure you have those. So here, of course, is how you're going to figure out x and y. Those two go together. And here is how you're going to figure out r and theta. So here we're going to have to use that inverse tangent value on that to go. So these two are going to be how you get rectangular. These two are how you're going to get polar. So let's practice just a couple of those examples, see how they work. Okay, so find the rectangular coordinates of the point with the polar coordinates. So again, if I want rectangular, I want these two conversion formulas. X is going to be r cosine theta. And then y is going to be r sine theta. Hopefully that makes sense to you. X is cosine, y is sine, like it is on the unit circle. So we're just going to calculate, substitute in and calculate. So 2 cosine 7 pi over 6. And as you type that into your calculator, you're going to just double check to make sure you are in radian mode, since you're typing in 7 pi over 6. Or you can convert it. If you remember what 7 pi over 6 is, you can certainly convert that. So that would be what, 2/10? Okay, but I'm just going to switch over to radians, go to mode, radians, and then I can type it in as is. So 2 cosine, and then type in 7 pi over 6 gives us negative 1.73, and then 2 sine 7 pi over 6, negative 1. Hopefully that is correct. So that gives you your x and your y coordinate. Okay, yeah, that's what I have. And so x negative 1.73, y negative 1. Okay. So that's how you convert from polar to rectangular. Okay, there's that example. And then of course, lastly, we're going to convert the other way and use the other two formulas on this next example. Okay, so the rectangular coordinates are 1, negative 1. Okay, so that's the x and that's the y. And we want to turn it into polar. So we're going to use the conversions. And if we just quick look back at our formulas, it's these two. So r is going to be x squared plus y squared. So we'll take a square root in the end, and then y over x for tangent. Of course, we know that. There we go. Okay, so it said r squared was equal to x squared plus y squared. Okay. And then it said tangent theta was equal to y over x. Okay, so we'll just substitute in 1 plus negative 1. Of course, we're going to square both of those. 1 plus 1 is 2, and so r is the square root of 2, and you can leave it as that, or just give me the decimal approximation of 1.414, that's fine. Tangent theta, so we can figure out theta, is y divided by x, so negative 1 divided by 1. Okay, so we're going to do inverse tangent on our calculator. Negative 1 divided by 1. Okay, I'm going to switch back to degrees because I prefer my answer to be given to me in degrees. So let me just do that real quick. Switch back to degrees. Inverse tangent of negative 1 divided by 1, which of course is negative 45 degrees. Okay, so my answer in polar coordinates would have a radius of square root 2 and a theta value of negative 45 degrees. Okay. But you'll notice it says 2. Okay. So we could rotate negatively, or we could rotate in a positive direction. So remember that negative 45 degrees, if I went 2 units out, and I could rotate negative 45 degrees and end up there. Or I could rotate in a positive direction and end up in that same location. So if I would just imagine going this way, I can end up in this very same location, but that positive direction would be 315 degrees, right? So this would give us the second possible answer. So, or same radius, square root 2, but instead of rotating negatively, I'm going to rotate positively. Okay, and give you that same location, just getting there in a different way. Okay, so what I want you to be able to do is just convert back and forth between rectangular to polar or polar to rectangular. So just remember that polar is out and around. so that's really it for this section. So nice and short little section, making sure you know where to find those formulas, and then of course how to use them. All right, so just 3 sample problems, give them a try, check answers once again. On number 29, I think it has you, it suggests save your answers in radians, but know that you can do it in degrees if you prefer. The degree measurement is the unit that you will want to use for your quiz. So you can practice it in degrees if you like, okay? So 6-4, questions 3, 7, and 29 in the shot, okay? Good luck. Again, contact me if you're having any issues.